talking about hardware push bots or hardware test bots. Basically what a hardware test bot is a declaration of all your hardware and common use values that you might use throughout your project. So for starters, let's go to the external samples and pull two things out of there. First, let's copy the hardware push bot and move it into our team code. So just do Command C, Command V. You can name it hardware push bot, that's perfectly fine. Wait for it to process and add it to Git, yes. The second thing you want to take is pushbot auto drive-by time linear. So the first thing we're going to do is just paste this. And now you add it, yes. And what we're going to do is we're going to import the external samples but from our team code. So what I want to start with is on line 69 and 70 in the pushbot auto drive-by time linear. Delete that. And then after the wait for start, so starting from line 86 all the way down to line 124, just delete that. And now you should have no errors in your code. The next thing we're going to do is import our own hardware pushbot in this thing from the team code. So we're going to do import org first inspires .ftc .team code .hardware pushbot. And what we're going to do here is hardware pushbot, and make sure you're selecting the one from the team code. Robot equals new hardware pushbot. So what we've just established is that we're using the pushbot in our team code, not the pushbot in the FTC robot controller or the samples. So let's go to our hardware pushbot now. And what you see right here on line 55 is a declaration of all the motors that you will use. So we have a left drive, left arm, right claw, and left claw. So right now you see we have 3 DC motors and 2 servos. But let's say, like most FTC robots, you have a 4-wheel tank drive. So you have 4 motors. What you want to do is just delete this, and let's make our names a bit more specific. Let's go left front, right front. And then what we're going to do is copy this and create a left back and right back. So let me just do that. Left back, right back. Now, since we don't have any servos, these doubles right here on line 62 to 64 are useless. So let's just delete the spaces. You can leave the next lines alone. Now here in our init is basically telling us what we want to do when we initialize our code. So, and how to initialize our motors. So for starters, there's so much red here because none of these exist. So I'm going to start off by deleting lines 93 to 97 as they're all servos. The next thing is these DC motors don't exist, so we'll just comment these lines out for now, as well as these ones. I'm going to delete again. I'm going to delete left arm. And right now I'm going to change left drive to left front. Change right drive to right front. And in the quotation marks, I'm going to change to left underscore front, and then right underscore front. And now let's just set the left motors to forward and the right motors to reverse. So what I'm going to do is first copy these. And then instead of left front, we're going to make it left back. Right back. Change them in the quotations as well. And then let's just copy these. The settings are directions. Left motors should be forward. Right motor should be reversed. Perfect. So now we've completed our declaration. What we're going to want to do is first, we're going to want to set all the motor powers to 0 and run them without encoders. So those lines that we just commented, we're going to uncomment them now. And we're going to change these variables. So we're going to go left front, right front, left back. I'm going to copy this. And get right back. Now we also want to set them to run without encoders, assuming you do not have encoders. If you are using encoders, you obviously want to run with encoders. So left front, left back, and then just copy it and go right back. All right, cool. So now what we've done is we've set up our hardware test bot. So now when we go into here and we want to call our motors, we can simply just say, as you see here, it says robot.init hardware map, and we've established our robot is using the hardware push bot. So now if we want to call our motors, we can simply just say robot dot, and as you see here, all our 4 motors appear. So we can do left front, and we can set power to 1. However, if we want to set all the powers to 1, it would just be easier to do it in the push bot. And this is the next usage of the push bot. In the push bot, what you can do is you can set functions. So a function is a repeated amount of code, or is a repeated set of code that you will use over and over again. As you can see here, I just created a function called forward. What does forward do? And as you can see here, there's an error on robot because I'm in the push bot. Therefore, there is no robot to define the push bot. I am simply just using left front as it's already defined locally in this code. So I'm going to just set power to 1. Let me copy this for the rest of the motors. And then change the names. So right front, left back, and right back. So now in our drive-by time, let's say we want to go forward for 1 second. Instead of having to write out all 4 words, I can do robot.forward, just like that, and sleep for 1 second, which is also 1,000 milliseconds. Now obviously this doesn't make much sense, as if we were just going to type out that code once, we typed it out in a different place and had to call it. However, if forward is something you plan to use over and over again in multiple different autonomouses and your teleops, then it is useful to have it in your push bot, as you don't have to keep recoding it or copying it from files. Now let's say that 1 is too fast of a speed. What we can do here is we can add a parameter. So as you see here, I've added a parameter called speed. And now I'm going to set, instead of setting the powers to 1, I'm going to set the powers to speed, whatever that may be. So now you can see there's one related problem. So if I go back to our forward, there is no speed defined. So what I'm going to want to do in the parentheses is type in 0.6. So as you can see here now, I've lowered the speed to ensure that our robot will move fine. So there you have it, folks. This is how you create a push bot and are able to use it in your normal codes. If you want to declare more hardware, you add it right here. You simply will map it right here. Set the direction if it's a DC motor or servo. And then after that, you can continue out, changing it if it's a DC motor. And outside of this init statement, you can create functions like the one I just made, call forward. Thank you everyone for watching. We are the Tacobots, and we hope you tune into more videos. Please remember to like and subscribe.